Hi everyone, welcome to a new video. In the previous couple of videos we've introduced the logarithmic graph and we've also talked about some of the transformations that come with those. So all we're going to do in this video is put everything together to look at sketching some log graphs with multiple transformations. Now we're going to do two questions in this video. The first one is we want to draw the graph of y equals log to the base 2 x minus 3 plus 2. Okay, so this is our first graph, and we basically want to, like we've done with a lot of previous graphs where we start at one point and we start with our sort of basic graph and then apply the transformations, we're going to do the exact same thing here. Now, with our regular log graph of, let's do it in purple, this one here, y equals log, and we'll do this to the base 2 of x. We have an x-intercept at 1, and we have an asymptote at this line of x equals to 0. Okay, so we want to consider all of the different transformations here. Now let me shift this graph over to this side a little bit. Now, we want to consider what is this thing doing and what is this thing doing. Now, if you guys remember from when we first looked at transformations, we identified what these were. So this is obviously a little bit of a recap of what we did before. Now, if something's acting on the x, we're going to shift it left or right. This is a horizontal shift. And we shift it to the opposite side of what the sign is. So this is x minus 3. So this is a horizontal shift 3 units to the right. And this guy over here is our vertical shift. And this shifts it 2 units up. So I have two different transformations we're working with, and I want to do these one by one. Now, remember with these transformations, they are going to shift all of the parts of this graph. So not only will they shift the graph itself, as well as certain points like the intercept, they're also going to shift the asymptote over as well. Now, if we look at this, let's start with the shift 3 units to the right. So this thing is going to get shifted first 3 units to the right. So if I do this, my asymptote is going to go from x equals 0 to x equals 3. And my intercept here of 1 is going to get shifted 3 units as well. So instead of the point 1, 0, we have the point 4, 0. So if we draw this thing here, we're going to get something looking like this. So this is my y equals log to the base 2x, to the base 2 x minus 3. We are now showing my 3 shifts to the right in the horizontal direction. And now we need to take into account our vertical shift. So everything here is going to get shifted 2 units up. Now, the asymptote, of course, is just a constant line. So if we shift up or down, that doesn't change my asymptote. But it's going to change my points here. So first we have a shift of 3 units here, and then now we want to move 2 units up. So every point on my log graph is going to go up 2 units, and a specific point we have here is the point 4, 0. So that's going to go up 2 units. So let's do that in a different color. Let's do that in blue. So it shifts up 2 units, and let's actually clear up some of this, because now we're getting the idea of how this looks. We want to shift this up 2 units. We've shifted it right already, so I can get rid of that. And this will look like something like our previous red graph, but going up 2 units. So it's going to look something like this. Where this point here got shifted up. So my point here, since it was originally 4, 0, it's going 2 units in the y direction. So this stays at 4 in the x and goes up 2 units to 2. So this is our new point, and we now have a different intercept, don't we? Because our thing's been shifted up. So we're going to have to calculate that intercept real quick. So I'm just going to do that on the right here. So if we shift everything across, we can now think about calculating the x-intercept. So we have our graph of y equals log to the base 2, x minus 3 plus 2. And we have an x-intercept when y equals to 0. So I'm going to set y to equal 0, and I have log to the base 2 of x minus 3 plus 2. And I'm going to rearrange the equation. I'll subtract 2 from both sides. This gives me negative 2 equals log to the base 2 x minus 3. And now I can write this, in order to solve this, because we talked about this before, I can write this in exponential form. So this is my power, this is my base. So I have 2 to the power of negative 2 equals to x minus 3. And I can just add I can add 3 to both sides. So I get that x equals to 2 to the power of negative 2 plus 3 equals x. So our x is approximately, once you put this into your calculator, 3 1/4 or 3.25. So my new intercept is over here at 3.250. So this is how we can apply our transformations to draw a new graph and calculate other things as well. So calculating new intercepts when these things get shifted up and down. Okay, let's look at one more example. So in example 2, we are trying to sketch the graph of y equals to log to the base 5 of x plus 2 minus 1. Okay, so let's draw this, once again starting with our regular log graph and then applying the transformations. So we have this thing over here. Actually, let's shift this across. Okay, now we're going to start with our regular one. Let's do it in purple again. So this is my regular log graph, y equals log to the base 5x. And since this is log to the base 5, we'll probably want to make this a little bit steeper. Or sorry, steeper here, and then a bit more of a gentle increase up here, because remember in the previous videos we talked about the effect of this base number here. Now when you do these, you can also include a point of scale as well, but just for time's sake, I'm going to avoid doing that here. Alright, so we have this, and now we want to apply our transformations. So we've got this graph, we've got our intercept of 1, 0, and we still have our asymptote at x equals to 0. Now, let's apply everything little by little. So we have our horizontal translation, and we have our vertical translation. So my horizontal one, starting first, this is going to be a shift 2 units to the left. So very similar to what we've been doing with all of our previous function transformations. If any of this is new to you guys, please feel free to watch some old videos to catch you up on that. I'm doing this assuming we're familiar with this. Now, if I draw this, I'm going to get something looking like this. And everything has shifted to the left. So my asymptote has gone 2 units to the left. It's now x, the line x equals to -2. And my intercept has now gone 2 units to the left. So from 1, 2 units to the left gets me to -1. And I still am at 0 here. So I have done the first bit, this bit I've highlighted in blue up here. So this is the graph y equals log to the base 5 x plus 2. And we're not quite done yet. We still need to do our vertical shift. So we are going down 1 unit from here. So everything is going to get shifted down 1 unit, including a significant part of this, which is my intercept. Now, if I just temporarily get rid of these so my diagram's not too messy, we can start to shift this down. Alright, so one thing that's particularly going to go down is my intercept. So that point goes down to here, -1, -1. And this means that my intercept, of course, is going to change, because as I draw this, because everything's been shifted down, I'm going to get something looking kind of like this, basically. Let's do that again. And it's going to keep going. Now, we can find both of our intercepts as well. So, firstly, let's try our x-intercept here. We want to find this guy here. Now, that's going to be found out by letting my y equal to 0. So I've drawn in all the significant points here. Now I just need to find an intercept. Okay, here we go. Move this here. So I can find my x-intercept when y equals to 0. So I'm going to have 0 equals to log to the base 5 x plus 2 minus 1. Bringing the 1 over to the other side, I get 1 equals to log to the base 5 x plus 2. And now finally, to solve this, again, I'm going to want to put this in exponential form. So I have my base of 5, my power of 1. So I have 5 to the power of 1 equals to x plus 2. 5 to the power of 1 is just going to be 5. So moving the 2 over, I get that x equals to 3. Okay, so my intercept here, my x-intercept, is going to be 3, 0. Now, we can find the y-intercept as well, but to do so, it's gonna require us to use something that we're gonna do later in this course. Now, I'll show you guys what we're gonna be doing, but I'm gonna more formally introduce it in a later video. Now, let's just find the y-intercept, because now we actually have one. So let's find this guy over here. Now, if you remember, we find our y-intercept when x equals to 0. So, substituting 0 in for my x in this equation up here. So, my y equals log to the base 5 of 0 plus 2 minus 1. And that gives me log to the base 5 of 2 minus 1. And what we're going to do here is something called a change of base. So I'm just going to do it now, but I'll properly explain it in a later video. Now, when we have something to actually put this into our calculator with these two different, with a base that's different to our number there, we can do a change of base. So a lot of calculators we can use a function which gives us log to the base 10. And this is what we call a change of base rule with logs. So we can change the base to something that is the same top and bottom, where the numerator is this value here, and the denominator is this one here. Now, don't worry too much about this. This is just an extra thing just so we can find the intercept. We will talk about it a lot more in future. Now, this thing gives us approximately, to 2 decimal places, negative 0.57. To 2 decimal places. So this guy over here is going to be 0.57. But I know there was a little bit extra that we added here, but this is basically how we can sketch these multiple transformations for log graphs. They work the same way as our parabolas, our exponentials, our hyperbolas, all of those things we've looked at in previous videos. They work in the same way. But just the way we find intercepts and the things that get shifted, like the asymptote, are going to be important for things like this. And we can, when we do these, you can also include a point of scale if you'd like. I mentioned that before, just so you can really show that this is, for example, a log to the base 5 compared to like a log to the base 2 up here. But we'll wrap it up here. This is how we can draw logarithmic graphs with multiple transformations. Thank you so much for joining me, and I'll see you next time.